Let's do this. So, reminder, it is a Wednesday, so there is review session after lecture for 2 hours after lecture on Twitch. If you're struggling with anything, please take advantage of that. They'll go over, the TAs will go over the previous week of content, and they'll answer any questions that you want. Last time I invited you all to go and ask them tons of questions, and, well, it just didn't happen. They ended up closing the stream 45 minutes early because nobody was active. 15 minutes went by, nobody asked a single question, so they left. So if you're struggling with any of the concepts, especially, like last week I expected it to be really packed because point of sale was coming up, and then the point of sale checkpoint went and half the class didn't have it done. Like, go take advantage of the resources. Take advantage of this review session is especially underutilized. Go take advantage of it. Ask some questions and stuff. Or if you don't want to, if there's a reason why not to, talk to me or talk to the TAs about it, and maybe we can make some adjustments. But there's a review session. They'll review things. You can ask some questions. They start with a review of the week and then open it up for questions for the rest of the time. So come there with your questions. Even if you still have point of sale questions, if you have an extension, ask them your point of sale questions. They'll be happy to help you. I was kind of sad that they just ended stream early because nobody was taking advantage of it at all. So I don't know what to do about things like that. And just a heads up, if you're not doing super well on Learning Objective 2, if you needed the makeup quiz and interview, and you didn't finish point of sale by the checkpoint, at least half of the class, most of the class is in that same boat. The quiz and interview especially was very poor on LO2, which we have makeup opportunities for a reason. You can use those. But if you're struggling in the course, like most of the class is, take advantage of the resources. We're trying to help you out. So it's always frustrating to see students struggling and then not taking advantage of the help that we're offering. So if there's a reason, why not? If we can improve the course, let us know. But maybe you just don't like that format or something. Maybe we can do a review session in a different format. I don't know. But let us know how we can help you. It seems like the only help that's taken advantage of is one-on-one help in office hours, which 248 students in this class registered. We just can't one-on-one help every single student, unfortunately. Sup, Dragos? Sup, Cole? Weird Alex? Yeah, this week's the LO2 Makeup Lab. So if you don't have credit for the interview and quiz for LO2, which is most of the class, head to lab. If you have credit for both of them, you're doing awesome, first of all, and you can take the week off of lab. All right. With that, anybody have any questions before we get into it? I'm just going to get into lecture mode and present some slides. Yeah. Review sessions are on Twitch. So it's a pinned post on Piazza. Oh yeah, I should say where review session is. It's a pinned post on Piazza labeled, I believe, just review sessions, and then it has a Twitch link, and then you can watch a stream on Twitch. Stream starts 20, at the hour after lecture. So I forget what the timestamps are. 20. When does lecture end? 2:40, right? So 20 minutes after lecture. The review session will start. And they'll go to 5 o'clock as long as people are asking questions. But they're not going to waste their time if nobody's asking questions. They'll shut stream down early. So get in there and take advantage of that. It was a full hour where nobody was taking advantage of that. But yeah, check it out, the pinned post. I believe it's the top pinned post still, unless another one was pinned since then. Check that post out, and that'll have the Twitch link. And now they were even inviting students last time. I shouldn't say this because you're all going to, a lot of you might do this, but hey, if that's what it takes to get it utilized, is they were inviting students to post their code on Piazza, and then, Piazza. Post their code on Piazza, and then in chat, message your Piazza link number, and then they would look at that post and then give you a specific answer about your code. Basically office hours, but in a group setting where other people can benefit from the answers of your question. When they're offering that, there's no reason not to. Especially with if the whole class was doing a lot better, if LO2 went super well, it would be whatever. But with L2 going so poorly and review sessions just sitting there waiting. Oh, I love having review sessions. It's something like logistically, it's easier since it's on Twitch, but logistically getting a review session rolling is usually pretty tough. And we have one, and then to see it underutilized is always sad. Yeah, post your code in lecture chat. I think that's my guess is why it's underutilized, is you just want to say, here's my code, tell me what's wrong, which I get that, understand. But when they're offering Piazza posts and to look at those, there's no reason, there's no excuse anymore that I can see. If there is one, let me know. All right, but anyway, that's enough of that. I don't want to spend too much time talking about that kind of thing. But let's talk about WebSockets. So we have this problem when we're building web apps. Like in 1.15, you built a web app that had some endpoints. The users would contact your endpoints through your front end and get some information, and it was a request-response protocol. That's how most websites work. And then in lecture in 1.15, I hope they're still doing this, or else you won't know what I'm talking about. But in lecture, they built a chat app that used polling. New messages as soon as they appear on the server. So when somebody sends a message, there's no way for the server to say, hey, there's a new message, here's what it is. We had to use something called polling, where each client would just send a request at a regular interval. So like every second or so, the client would send an AJAX request and say, hey, you got anything new for me? 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 And just keep sending these requests every second. And then when the server would respond with the chat history, and if there's something new, the client would be able to update it and see that. This is good, but two big problems with this. It causes a lot of extra network traffic. If every client is sending a request every second, that's just a lot of requests being sent, a lot of network traffic. And two, you have to wait a while for a message. You might be waiting for up to a second before you're seeing the newest chat message. Now, those are kind of, you can adjust the timing on that. So maybe you want to limit the network traffic added, so you change the polling to 5 seconds, but now you're waiting up to 5 seconds for a new message. Maybe you don't want to wait long for a new message, so you change the polling down to 1/4 of a second. Well, now 4 times a second, everybody's sending a request. So it's hard to find like a happy medium with polling. So there is a solution, long polling. I won't talk about this one in detail, but in short, the server, when it gets a polling request, it's going to intentionally hang on that request and only respond to it when there's new information to be sent to the clients. So it effectively finds that happy medium. You can long poll if at longer intervals, and then when the server has something to send, they'll respond to that, and then you send another long poll request. The solution we're going to use is WebSockets. It's a little newer. It's starting to get, it's older now. It's over a decade old now. But in 2011, WebSockets became standardized, and our browser started implementing WebSockets. So we can use these in our web apps. And WebSockets are awesome, so that's a good thing. So what a WebSocket does is creates a persistent connection. So instead of a request-response protocol, WebSockets are saying, hey, let's just open up a connection between client and server, keep that connection open, and let both sides communicate over that channel. So now if the client has information it wants to send to the server, just send it over the WebSocket. The server has information to send to the client, just send it over the WebSocket. So we have bidirectional communication through this open channel that's always open. So now the server has new information to send to a client, just send it over the WebSocket. That connection is just always open, no delay, no long polling logistics, no polling, none of that. We're just going to say, oh, yeah, that client has a WebSocket connection open. Just send them a message over the WebSocket. So this gives us some nice features. One, the server can communicate to the client without waiting for an HTTP request. And two, we get real-time updates. So if a client wants to send a message to another client, they have to go through the server. But if they both have WebSockets open with the server, client sends over their WebSocket, server sends over the other WebSocket, No delays, no messy logistics. Just use these open channels to communicate. To work with WebSockets, we're going to use a library called Socket.io. This adds a few layers on top of WebSockets. I won't dwell on the details too much, but I do want to go over just a few features of just to answer the why Socket.io question. Socket.io simplifies a lot of things with WebSockets. WebSockets just offer that persistent connection and the ability to pass messages, pass content between server and client. Socket.io is going to give us a few nice quality of life things. First, it's going to maintain the connection. If the connection gets severed for whatever reason, Socket.io is going to send a reconnection request. It's also going to keep that connection alive and make sure that you don't have clients that disconnected that are still taking up memory or anything. It's going to add the idea of message types, which is going to make our use of WebSockets feel a lot more like our use of actors, which is why the primary reason why I use it in this class. We're going to have message types, and then based on the message type, we can either have data that we're sending along with that or not, which is correlated to our case classes and case objects. Those are going to be our message types that we're going to send. But they do have to be strings in Socket.io. And then we're going to have listeners, which listen for the different message types, very similar to our receive method in actors. We're going to listen for each type, message type, and then react differently based on the type of the message that we receive. So since Socket.io is a new library we're using, add it to the POM, install everything from the POM. Irrelevant these days because I just put the full POM for the whole course in the examples repo right away. So again, you don't have to worry about these. But if you were adding this to a new project, either take my POM and just use that, that's fine. I'm fine with that. But whatever you do, make sure that Socket.io is in your POM file. For all these new libraries that we talk about, the Scala effects, Java effects, and any other libraries, Scala tests, if you're creating a new project and doing something outside this course with Scala, just make sure your pom.xml has the libraries that you need in it, and make sure that those are being downloaded. Because those are all external libraries. We use a lot of external libraries that are not included with Scala. The pom.xml is our way of telling Scala, hey, go download these extra libraries for me because I want to use them. All right, so let's get into the code and see how we're going to use WebSockets. So I'm going to start with the server, and we're going to see server and client side. We're going to see both ends of the communication here. So with the server, first, I want to import all my good stuff from that library. I got all kinds of things that I'm going to import. IntelliJ is pretty good about auto-importing. You just start writing this code, and it'll be like, hey, you need to import all these things, and it'll import them for you. But we do have to import from that library, so we can start using that code. We start using the classes and objects from that library. Next, we're going to set up some configuration. It's going to be where we're going to listen for WebSocket connections. Now, I want to listen for WebSocket connections on just localhost. For my purposes here, I'm just going to be using my local machine. And I don't have a host name. And port 8080. So whenever I get a connection on port 8080, I'm going to listen for that. If it is a WebSocket connection request, I'm going to be able to handle that and connect to whoever's trying to connect to me via WebSocket on port 8080. I'm going to create a new WebSocket.io server, which is from the library. Right here. Give it my configuration, and that's going to give me my server. And then I want to start the server. Once I start the server, it's going to reserve port 8080 and start listening for connections on that port. So that's the structure, that's like the boilerplate of how to set up the socket server. Once we have all that, we have a socket server listening on port 8080 for these WebSocket connections, but it doesn't do anything yet until we start talking about this stuff. And this is what we'll spend the rest of the time talking about the server side. It's talking about these things. How do we get it to do the things that we want it to do? How do we actually implement like an app that uses these WebSockets? So for that, we're going to use listeners. And you'll see throughout this lecture, we're going to use some OOP and some FP at this point. We're really done. We're pretty much done with the FP topics. I mean, technically this week is in the FP and concurrency, but FP was the previous 2 weeks. So we're transitioning to the part of the course where we just use objects, we use functions. We're going to start using them whenever they're applicable. to our code, whatever solution fits the problem that we have the best, which is often a matter of opinion. In this case, it's not because the library forces us to use OOP, but we're going to start using OOP and FP for the rest of the course in our examples and in our code. So for this, we're going to add connection listeners to the server, or add listeners to the server, and those listeners are going to listen for different event types to happen. And it's going to listen to these things concurrently, of course. We're going to have different events occurring from different users, which can happen concurrently. These will all could have simultaneous events. We have to have all this code running concurrently. We want our server to be able to handle multiple clients. If we have persistent connections, if I'm not running concurrently, I'm going to have one client connect to my server, and for the rest of my server's life, it's communicating with that client and doing nothing else. If we have this persistent WebSocket connection, that's the only thing my server can do now. We need our code to be concurrent, and this is a good interview answer, part of an answer. We need our server to be concurrent because we need to have multiple connections with multiple users open simultaneously. So if we want a WebSocket connection, which is a persistent connection, not just a request response, like if I have a whole bunch of users and I'm just request response like HTTP, I can one at a time, request response. I can do those one at a time. It's not going to be very performant, but it'll work. With the WebSockets, since I need persistent connections, if I'm not concurrent, I can only have one user using my app, which isn't a very interesting app. You're going to host your app on the web and say, only one at a time. That's not an interesting app. Nobody wants to use that. So since our code is going to be concurrent, which the library takes care of for us, since the library is going to be concurrent, we can handle multiple users simultaneously. And we can scale our apps up, have many, many users. And we do that through these listeners. So our server is waiting for connections, and then whenever there's a connection, a disconnection, or any message sent over any socket, we're going to have our listeners handle that, and they're going to handle that concurrently using an event-based architecture. When some event happens, use my code to be able to handle that event. So I have this connection listener, disconnection listener, and message listener. These are all classes that I've created, so let's see what these things do in our code. So let's start with connection listener and disconnection listener. When we add a connect listener or a disconnect listener, those have to be of type connect listener or disconnect listener. Those are classes from the library. If I go back here, these are imported from the library. And I'm going to extend those classes. These are abstract classes. Actually, I think they're traits. These are abstract. So we're going to extend them and then complete the implementation. So when I extend them and create connection listener and disconnection listener, which are my classes, I'm going to extend this and override the onConnect method, which takes a reference to a socket. This method is going to be called whenever a user connects or disconnects, depending on which one we're writing at the time. And now with this setup, I'm going to add that listener to the server. Now, whenever somebody connects to this server, it's going to go to my connection listener object, call its onConnect method with a reference to the socket, which belongs to the client that just connected. At that point, it's up to me, whatever I can code. I'm just printing to the screen because I don't want a complex example for your first example. I'm just printing to the screen, somebody connected to me. But this is where we would do whatever logic we need. Usually initializing data structures at this point, somebody connected, let's store in some data structure the fact that this user is currently connected, and then when they disconnect, we would remove them from our data structures and say, okay, they're no longer connected. I don't want to remember this client anymore. Disconnection listener, disconnect listener, same exact structure. On disconnect is going to be called every time a user disconnects, assuming it's added to a server through add disconnect listener. And then run our code. I'm just saying, hey, this client disconnected. But that's where I would add logic and actually do whatever I want to do whenever somebody disconnects. Maybe remove them. Maybe it's an app with chat, and I want to remove them from the user list of that current chat. But it's whatever we can code there, whatever we want our app to do. All right, next, and a little more complicated, is what happens when a user sends a message. So whenever somebody sends a message, we're going to react based on the message type. So here I'm going to add an event listener, which is going to listen for messages of type chat message. Now this is similar to the name of our case objects and case classes in actors, but the message types are always strings when we're dealing with the Socket.io library. These are always strings. So I'm listening for a message of type chat listener. I'm going to give it the type of the data that I'm expecting. For all my examples, I'm either going to use string or nothing here. We could have other types sent over our WebSockets. I'm going to stick with strings, and then we can parse those strings to extract more meaning out of them. And then I'm going to give it a new message listener, which is a class that I wrote, which extends data listener of string. This string here, and this string here, these can be any type we want, but they all have to match. They all have to be the same. So if I'm giving this the string class, then this message listener has to extend data listener of string. And if data listener has a type parameter of string, then its onData method is going to take a string as its data type. So once we have our message listener, once we extend data listener, we have one abstract method to implement, just like our other listeners. We just had one, and this is onData. OnConnect, OnDisconnect, onData. When the event happens, on that event occurring, we're going to call this method. So the event here is receiving a message, and we're going to get 3 parameters when this method is called. A reference to the client socket, just like we did with connect and disconnect. But now we're going to have some extra stuff. We're going to have the actual data, which is a type that matches the type for this listener, in this case, string. So the string, the actual data. So somebody sent us a message of type chat message, where the data is whatever message they're sending to chat. So this data is going to have that data from chat that they're sending to chat. And then an ACK request, which we're not using in this course. This is if the client is requesting that we send them an acknowledgement that we received their data. We're not going to worry about that one in this class. But we do have to have it. It's part of the method signature of the method that we're overriding from the data listener class. So we do have to have that parameter even though we're not using it. And then it's whatever we want to do with that stuff. Again, I'm just printing it to the screen. And then if we want to send messages to the client, which is one of the big selling points of WebSockets, the server can send messages to the clients. We can use this send event method. If we have a reference to a client socket, it has a method called send event, and it's going to take either 1 or 2 arguments. So it's going to take 1 or 2 arguments. The first one is the message type that we want to send. So I'm sending a message of type ACK, short for acknowledge. And if I have a second argument, that argument is going to be the content of that message. So I'm sending an ACK, a message of type ACK, and the message I'm sending is just, I received your message, hey, I got your message. If you only send one, so this is kind of like a case, class, where I'm sending a message of some type with some information attached to it. If I only use one parameter here and I just have the message type, that's similar to sending a case object to an actor like we saw on Monday. So if we want to do that, if we want to simulate a case object, we just want to say, hey, some event occurred, and we don't have any information to attach to that event. Our type here, we're going to change that to nothing. So all those strings convert to nothing. There's nothing to read from the data, so we better not access that variable. We're going to extend data listener of nothing. And on data, we're just going to use this socket if we need, or we're just going to update the state of our app, or whatever we want to do with this message. But we're just saying, okay, we received a message of type ping. We received a message of type ping, so we don't really care about any information with a message of type ping typically. We're just going to respond with pong. A common networking thing, if you haven't seen that before, just receive a ping, respond with a pong. It's a good thing that we use it's something we use for testing, just to make sure network connections exist. We usually use it for latency testing. If you do ping in your terminal, you're doing that usually to tell how much latency you have between a server. How long does it take from sending the ping to receiving the pong. That's your network latency. And there's no processing here, so you're not adding latency from the processing of the server. You're just testing the network latency. So that's one of the reasons we like ping pong. But if you haven't seen that before, it's something you'll see fairly often in this industry. Okay, so that's quite a bit. Anybody have any questions with this? And again, under the notion that I won't ask you to write WebSocket code. And I already told you it won't be on a quiz, but in an interview, a fair question would be like, why did Jesse spend a lecture talking about WebSockets? And in the context of concurrency, like how is concurrency important in WebSockets? Those would be fair questions. Are we going to use anything web-related in this course for the project? So project 4, the starter code I give you, will use the content from this week. You won't be asked to write it, but it will be there in the project. And if you can understand and read that code, it'll just help you understand what's happening with the project as a whole. I think it'd be harder to write the project if you didn't understand anything from this week. It'd just be hard to understand the starter code. And seeing where the code you write actually fits into the bigger picture. Yes? Homework 4, the next one. The enemy AI. It's not released yet. All right, let's talk about clients. So let's talk about web clients. So great, we have a server running, but how are we going to connect to it? What does it even do? So let's talk about web clients. So we're going to build a website, just a very basic one, just a little HTML and JavaScript, to be able to communicate with our server. So here's my HTML. I'm not even going to throw in any CSS. It's not going to be a very appealing page. It's just going to exist. So let's talk about the new bits here. So I want to use a Socket.io library. So if I have a Socket.io client library and a Socket.io server library, they're going to know how to communicate with each other. So I'm going to pull in a Socket.io client library, which knows how to connect to my Socket.io server, knows how to communicate with it, knows about message types and pings and pongs. This library itself has a ping pong that it uses to check if the connection is still alive, and it has to send the ping periodically. If the server doesn't hear a ping every once in a while, it's going to assume that client's disconnected. So anyway, I need to import this library. I'm just going to import it from this CDN. So every time somebody loads my page, they're going to have to send a request to this CDN to get my code. Of course, it all happens automatically by the browser, but the browser is going to send a request, download this code, so I can use it in my project, in my app. I'm going to set up just bare bones HTML to be able to send chat messages. I have one text input, so the user can type their chat message, then one button that they can click, which is going to call the send message method function, which is a function that I'm going to write in JavaScript, which I'll show you in a slide. And I have my JavaScript that I have to run, so I'm going to download my JavaScript as well. If you're wondering why I put this down here and this up here, I'll try to give the short answer. But this code has the WebSocket connection code, and if I put it at the end of the body, I know that my website exists and is loaded at the time that this downloads. So once my code downloads, it's going to run immediately. So I don't want this downloading and running before my elements exist, because I reference these elements. So if I put it in the head, there's no guarantee that my page is going to load before it's downloaded. This code up here, this is a library. I could put it down here, that's fine. But I can put it in the head too, because there's no code that runs when that downloads that has to interact with my site. I'm just going to call functions and methods and use the classes in this library. That's my short answer to why those are in two different spots, in case anybody was wondering. Okay, that web client.js, this code inside here, that's this file. And the first thing I do here, so as soon as this code downloads, it's going to run, and it's going to connect to my server. So this is the code that I need to connect to the server. This transports WebSocket is optional, but I like to have it. This forces the library to use WebSockets, which Socket.io surprisingly doesn't always use WebSockets. It was surprising to me, at least. It'll default to long polling in some cases. So I'm going to connect to my port 8080 on my server, and it's going to give me a reference to the connection, to that socket connection that was created. And I can use that socket connection, that reference, to be able to send and receive messages from the server. So to receive messages, I'm going to use the on method. I'm going to take the reference to my socket, call on, give it a string, which is going to be the message type. And this is read, when this socket receives a message of type ACK, call this function. So here I promised you FP, here's some FP. We're going to create a JavaScript function and pass that function as an argument into a method call. So we're calling the on method of the socket class and giving it a function as an argument. And we're going to define the whole function inline just like we did with Scala, but of course with different syntax. So this function is going to be called whenever we receive a message of type ACK. And the parameter to this function is going to be called with any of the data that's part of that message. So if this message has any extra information, it's going to be in this event variable. And I just have some code to add that to the HTML, add that to the page so I can display it to the user. If we want to send a message to the client, we're going to use the emit method. We're going to say socket.emit. And then this works just like we did with send event on the server side. This is going to take one or two parameters. If we give it two parameters, that's like sending a case class or an object of a type of a case class, where the first parameter is, the first argument is the message type, and the second argument is the content of that message. That's what I'm doing here. I want to send a chat message, and I want to actually send, I'm pulling from the input, getting what the user said, and then sending a message of type chat message to the server with the contents of that message, whatever somebody wanted to chat to this server. If I only had one parameter, if I just said socket.emit of Pong, that's going to be like sending a case object, and I'd send that case object to the server, just saying, hey, there's an event of this type. I have nothing else to say about it. It's just a ping message. Okay, let's keep on cruising through. And desktop clients. This is the beauty of web stuff. When we have a server running, a server that speaks any web protocols, WebSockets in our case now, right now. When we have that server running, it doesn't care what the client is. It doesn't care anything about the client except the fact that the client speaks WebSockets for this example, or speaks HTTP in other web examples. The server doesn't care. So typically we build websites, like we just saw. We build a website, and then that website communicates with our server. But we don't have to. We can write other code that doesn't run in a browser that communicates with our server. Like any desktop game that you play that has network capabilities. That's a desktop app. It's not a web app, but it still communicates with a server that's running using internet protocols. So we're going to do the same thing here. We're going to build a GUI. We're going to see how we can build just Scala code that connects to our WebSocket, and we'll eventually build a GUI. We should be able to get to that. So there's another new library. We're going back to the world of Java. So we're going to get a Socket.io client library, where before it was a Socket.io server library. We're going to grab a client library. So again, make sure that's in your pom.xml if you want to use this stuff without using my pom.xml. So similar ideas. We're going to import all our stuff from this new library. And this would be in a separate project, by the way, separate file at least. And we're going to connect to our server. This is going to look very similar to the client code in JavaScript that we just saw. We're going to connect to the server. That gives us a reference to the socket. Oh, after we call connect, I guess. And then whenever we receive a message, we're going to use the on method. On messages of this type. Call this function, okay, but this library uses OOP, so we're going to call a method of an object of this type. So we're going to create a new object and then call a method, where the JavaScript library liked functional programming, that we pass it a function. Different libraries have different ways. Just know how to use OOP and FP, and you can use all kinds of libraries. No matter what the library designers did, you can use whatever they use, whatever they happen to use. This library uses OOP, so we were forced into OOP for this example, for this library. So I'm going to create a class that processes my message, and I'm going to extend emitter.listener from the library. So the structure is a little bit different with this one. Emitter.listener has one method called call that takes a data structure of objects. Holy crap, what is that? So this is actually a Java class. This is a Java library that we're just pulling in to Scala, into our Scala code. So object is a Scala class. It's the equivalent of any in Scala, but it's Java's version of that, or rather any ref. It's Java's any ref. Java doesn't have an equivalent any. So this star means that it's going to be a data structure. So what we're going to do is grab, just based on how we're using our app, I know that I only want one string being sent. So I'm going to make a strong assumption that I only want the first element and that it's going to be a string. So I'm going to convert it to a string class and then handle my message from there. And if this is like a ping message, like a case object with no data, I just would completely ignore these objects. I just wouldn't even do anything with them. But if there's data that I'm expecting, I'm going to pull that data and then work with that data. And to send a message, emit. Same structure, that should be sounding familiar. 2 parameters if you want to send information, 1 if you just want to send a message type. So here I want to send a chat message with some actual content. I'm going to say hello to chat. So if I run this program, it's going to say hello to chat, and then that's it. Now, if I want to interact with a GUI, we do have to do something a little bit different. We have to use this platform.runLater. This is actually a class that we're going to use, and I'm going to use a little different syntax just to show you something different, especially since I'm not asking you to code with this stuff. I want to show you some different stuff. This is a class that we're extending, and this is Scala syntax. We're going to give this a function, and we're going to be able to use functional programming syntax to be able to effectively create an anonymous class, create an instance of that class. That class extends the class that I want to extend and overrides that one method that we want to implement. So if we have a class that we want to override that only has one method and that method's abstract, Scala says, let's give you a little bit of shortcut syntax so you don't have to create a new class. Otherwise, you'd have to have class, give it a name, extends, platform.runLater, and we'd have to go through all that. We're going to skip all that and just use this fancy little syntax. If we want our code to run with a GUI, we have to do this, which is going to make sure that our code runs on the same thread as the GUI. GUIs are inherently multi-threaded, and just the way they work in JavaFX and ScalaFX, they're going to run on a separate thread than our main program. So if we don't have this platform.runLater, we're going to be running on a different thread with different stack and heap, and we're not going to be able to access the variables that we want to access. If we do platform.runLater, it will run at some later point in time, like probably a fraction of a millisecond later, and it's going to run it in that thread with the same shared memory as the GUI. So if you see that in the code, like I have my example in the repo, when you see that, don't panic. It just means I have to work with my GUI. Oh, I'm skipping that one. I said all that. All right, so let's take all this and see a chat app. Using all of this, using WebSockets. So let's do this. So here's my architecture for my chat app. Let's break this down piece by piece and talk about everything that we can do, put together quite a lot of technologies that we've learned about and put it all into this example. If you haven't felt that way already in this lecture, talking about overriding and classes and functions and functional programming and everything, a lot's all coming together. So our chat server, we run this, and it listens on port 8080. When this runs, what I didn't talk about yet, I'm also connecting to a MySQL database. So if you want to run the example, the chat app in the code, you do have to download and install MySQL and have that running on your machine so you can have the database to communicate to. Without that, you're just going to get an error. It's going to say can't connect to MySQL, connection refused, and you won't be able to run it. So you have to download and install MySQL, like we talked about way back when we talked about GUIs, right, at the end of OOP, at the end of LO2. So we're going to connect to the database. And then when a client, so then everything's up and running. When a client shows up, they want to connect. They connect via WebSockets, and then they'll send a register message, a message of type register, which contains their username. So that's registering them as a particular user. And if we had authentication, this is where authentication would happen. We don't have authentication, so we're just going to say, let's let them choose whatever username they want, and they'll register with that username. When they do register, we're going to talk to the database, get all of the chat history, and send that to the client in a message of type chat history with all of the chat history in a big old JSON string. The client's going to get that chat history and have some JavaScript that says on message of type chat history, here's a function that renders all that chat history to the page and adds it to my HTML so the user can see it. When we have multiple clients, they're all going to register. And in my server, I'm going to keep track of all of their usernames. I'm going to remember which socket connection correlates to which username. So I'm going to have a map or two to be able to remember those correlations. Now, whenever they send a chat message, somebody sends a chat message to the server, they're sending, I have it set up so they're only sending the message that they want to send. And since I'm remembering that this socket is associated with this username, I'm going to be able to attach their username to that message. So they have to register their message, and then I'm remembering that registration. So they send a chat message, insert it to the database, and also broadcast it. I'm going to broadcast it to all the clients as a message of type new message. So when a client first connects, they're getting all of the chat history, and then whenever there's a new message, they're getting that new message sent to them. So they're not getting all of chat history every single time there's a new message to be sent. We're only getting new messages, and we only get all of the chat history from the database when a new client connects. Get the new message and render it. So new message is rendered a little bit differently than the entire history. And then whenever somebody disconnects, my onDisconnect is going to say, remove them from my data structures. Where I'm correlating a socket to a username, I want to remove their entries from those data structures. All right. And we got time, we can do this. So here's the code. It's in LO3FP chat. So I have my chat server hopefully running, right? Yeah. So I have my chat server running just in case something went wrong. I wanted to make sure it was already running. And let me go to the web, and I can see my front end for this. So I have my, let me refresh. So when I refresh, I have to register my name. I'll be Jesse again. And then I'm going to get all of chat history and render all that chat history to the screen and send messages. And I can also have, what I already have running as well, is the desktop client, which I can't zoom in. So the desktop client, I'm registered as Hartloff, and I can send messages back and forth. I don't know, hey. And we can see that instantly. We're going to see that instant messages sent instantly over these communications. So we can see all that message, all those messages, and if we look at the logs, we can just see like what I'm printing from the screen. I can see what's happening for each one of these events, just see when they're happening, and I think that's all I want to talk about with this. If you're interested in this, all the code's there in the repo. You can look through exactly how all that works, but it works off all the concepts that I talked about throughout this lecture. And yeah, that's where I want to call it. I could talk about the database stuff, but we talked about that already earlier in the semester. I'm just going to call it right there and say, see you Friday.